Imagine looking up at the night sky. For most of human history, people believed the universe was static and unchanging. The stars appeared fixed in place. The galaxies, though unknown to ancient observers, were assumed to simply exist in a vast cosmic structure that had always been there. Even in the early 20th century, many scientists believed the universe was eternal and unchanging. But everything changed when astronomers began studying distant galaxies. They discovered something astonishing. Almost every galaxy in the universe is moving away from us. Not just a few. Not just in one direction. Almost all of them. And the farther away a galaxy is, the faster it appears to be moving away. This discovery led to one of the most important conclusions in modern science. The universe itself is expanding. But that leads to an even deeper question. Why? Why would the universe expand at all? What started the expansion? And perhaps most mysteriously of all, why is the expansion accelerating today? To answer these questions, we need to explore some of the biggest ideas in cosmology. Biggie Bungie gravity, space-time cosmic expansion, dark energy, the structure of the universe. And along the way, we will discover that the expansion of the universe is not just a strange observation. It is a clue to how the entire cosmos began. The universe was once thought to be static before the 1920s. Most scientists believed the universe was static. This idea even influenced one of the greatest physicists of all time, Albert G. Einstein. When Einstein developed the theory of general relativity in 1915, he discovered something surprising. His equations suggested that the universe could not remain perfectly stable. Gravity would cause it to either collapse inward or expand outward, but at the time, there was no evidence that the universe was expanding. So Einstein introduced a term into his equations called the cosmological constant. This term acted like a repulsive force that balanced gravity, allowing the universe to remain static. For a few years, this seemed like a reasonable solution. But then, astronomical observations began to reveal something unexpected. The universe was not static at all. The discovery of galaxies beyond the Milky Way. In the early 1920s, astronomers were debating whether spiral nebulae in the sky were part of our galaxy or separate systems. One of the key scientists involved in solving this mystery was Edwin Hubble. Using observations from the powerful Mount Wilson Observatory, Hubble studied special stars called Cepheid variables. These stars change brightness in a predictable pattern. By measuring that pattern, astronomers can calculate their distance. When Hubble observed Cepheid stars inside the Andromeda Nebula, he made a groundbreaking discovery. The nebula was far outside our galaxy. It was actually an entirely separate galaxy. Today, we know it as the Andromeda Galaxy. This discovery revealed something extraordinary. The universe was far larger than anyone had imagined, and it was filled with countless galaxies. But an even more surprising discovery was about to follow. The redshift of galaxies astronomers soon began analyzing the light coming from distant galaxies. When light from an object moves away from us, its wavelength stretches. This phenomenon is called redshift. Light shifts toward the red end of the spectrum. When scientists examined galaxy light, they noticed something remarkable. Almost all distant galaxies showed red. This meant they were moving away from us. Even more surprising, the amount of redshift increased with distance. In other words, the farther away a galaxy was, the faster it was receding. This relationship became known as Hubble's law. It revealed something profound. Galaxies were not simply moving through space. Space itself was expanding. What does expanding space actually mean? When people hear that the universe is expanding, they often imagine galaxies flying outward like debris from an explosion. But this picture is misleading. Galaxies are not moving through space away from a central point. Instead, the space between galaxies is stretching. A useful analogy is the surface of a balloon. Imagine drawing small dots on a balloon's surface. Each dot represents a galaxy. As the balloon inflates, the dots move farther apart. But none of the dots is the center of the expansion. The expansion happens everywhere at once. The same thing happens in our universe. Space itself is stretching. And as space stretches, galaxies become more separated over time. The evidence for the Big Bang. If the universe is expanding today, this suggests something important. In the past, everything must have been closer together. If we go far enough back in time, the entire observable universe would have been compressed into an extremely hot and dense state. This idea became known as the Big Bang. The Big Bang is often misunderstood. It was not an explosion in space. It was the expansion of space itself. Three major pieces of evidence support this model. 1. Galaxy redshift, as discovered by Edwin Hubble. Galaxies are moving away from each other. This indicates cosmic expansion. 2. Cosmic microwave background. In 1965, scientists discovered faint radiation filling the entire universe. This radiation is the leftover heat from the early universe. It is called the cosmic microwave background. It represents light, released about 380,000 years after the universe began. This discovery strongly confirmed the Big Bang theory. 3. The abundance of light elements. The early universe was extremely hot enough to fuse simple elements. Cosmologists predicted the amounts of hydrogen, helium, and lithium that should have formed. Observations match these predictions remarkably well together. These three lines of evidence provide strong support for the idea that the universe began in a hot, dense state and has been expanding ever since. But this still leaves an important question unanswered. What caused the expansion in the first place? Gravity should slow the expansion. If the universe began expanding after the Big Bang, gravity should gradually slow that expansion. After all, every galaxy attracts every other galaxy through gravity. Over billions of years, this gravitational pull should act like a cosmic brake. For decades, scientists believed that the expansion of the universe would gradually slow down. The big question was whether gravity would eventually stop the expansion entirely. Three possibilities were considered. The universe might eventually collapse in a big crunch. The expansion might slow forever, but never completely stop. The expansion might approach a stable rate, but in the late 1990s, astronomers discovered something shocking. The expansion of the universe is not slowing down. It is speeding up. The discovery of accelerating expansion in 1998, two independent research teams studied distant exploding stars called Type Ia supernova. These supernovae have nearly identical brightness, making them useful as cosmic distance markers. By measuring their brightness and redshift, scientists could determine how the expansion of the universe changed over time. The results were astonishing. Distant supernovae were dimmer than expected. This meant the universe had expanded more than predicted. In other words, expansion of the universe is accelerating. Something is pushing the universe apart. This mysterious force became known as dark energy. What is dark energy? Dark energy is one of the greatest mysteries in modern physics. It appears to act like a repulsive pressure built into space itself. Instead of pulling things together like gravity, it pushes them apart. Today, scientists estimate that dark energy makes up about 68% of the universe. Dark matter accounts for about 27%, and ordinary matter, everything we see, makes up only about 5%. This means the vast majority of the universe is made of things we do not fully understand. A possible connection to Einstein. Interestingly, dark energy may be related to the same cosmological constant that Albert Einstein once introduced. Einstein originally added it to keep the universe static. After the discovery of expansion, he reportedly called it his greatest mistake. But modern cosmology suggests that something very similar to the cosmological constant may actually exist. If so, Einstein may not have been wrong after all. He may simply have discovered the effect before there was evidence for it. The future of the expanding universe. If the expansion of the universe continues accelerating, the long-term future of the cosmos may be very different from what early cosmologists imagined. Over billions of years, galaxies will drift farther apart. Eventually, distant galaxies will move beyond the observable universe. The night sky in the far future may become almost empty. Some theories suggest the universe could end in a scenario called the Big Freeze, where stars burn out and the universe grows dark and cold. But this process would take trillions of years, far longer than the current age of the universe, which is about 13.8 billion years. Conclusion: a cosmic mystery, still unfolding. So why is the universe expanding? The short answer is that the expansion began with the Big Bang, the moment when space itself started stretching. Gravity should slow that expansion, but a mysterious phenomenon called dark energy appears to be accelerating it. Despite decades of research, scientists still do not fully understand why dark energy exists. But every new telescope, every new observation, and every new experiment brings us closer to understanding the fundamental forces shaping the cosmos. The expansion of the universe is not just a curiosity. It is one of the deepest clues about how the universe began, how it evolves, and how it may ultimately end. And in trying to understand it, we are exploring the largest questions science has ever asked.